Okay, so we got our key features of functions. I'm going to go through the domain first, right? I'm going to do the domain for every single one. So the domain is the x values, right? So things on the x values that are that are being asked for. So we talked about these are understood with arrows on the end. So over here at -7, -8, anything in negative infinity, this graph is going to actually go up to be there as well. So our domain is going to be from negative infinity to positive infinity for number 1. Okay, the second one, I'm going across. All right, I'm going to call this one number 2. This one we said had a dot here and a dot here. Okay, so it's a closed interval here for us. Our domain, all right, the domain begins at an x value of 0 and it ends at an x value of 6. And those are closed, so it'd be from 0 to 6 and closed interval. Okay, let's look at number 3. So here's number 3. All right, these were arrows on the end, understood to be arrows on the end. So again, our x values here, all right, that's going to be from negative infinity to positive infinity. Because, way over here at negative infinity, they're still part of that graph because it's still going down forever to negative infinity. And then as far as I go over here, right, on the x-axis, there still would be a piece of that graph because it's going up to infinity. So that domain for number 3 is negative infinity to positive infinity. Okay, let's look at 4. So 4 is this graph right here. All right, this is talking about the domain for this one. Well, it's got the arrows on it as well. So this, again, same reasoning, negative infinity to positive infinity for the domain. Okay, number 5. Talked about this had arrows on it as well, understood. Okay, so again, this is negative infinity to positive infinity. Okay, 6. 6 right here. This has a closed interval on the left-hand side and a never-ending interval on the right-hand side. So this domain starts, all right, at an x value of, what do we say? This was 1 and this was 2. All right, and this was 1, this was 2. So we said that domain should start, that's at 0.5, and it goes to infinity. All right, number 7. This is never ending. So the domain is negative infinity to positive infinity for number 7 as well. Okay, now let's talk about the range. So let's kind of switch gears a little bit. And now we're thinking about the y values. So we're no longer looking at x values. We're only caring about these numbers here on the y-axis. So my range, all right, I put my pencil on the negative infinity. There's nothing down here on the graph, all right? I don't have anything until I hit the value of y equals 1, all right? So my range is going to begin at 1, and it's going to go up until infinity because my y values start at 1, and they go up in the positive direction to infinity. So question was, why is there a bracket right here? And there's a bracket because this 1 right here is included. So 1's got to be included. Okay, let's look at the range for number 2. All right, so my range, again, it's the y value. So it's from here to here. Okay, both of those values are included. There's no open circle. They're both closed circles. All right, and those values go from, that's 1.5 up here, and that's -1 down here. So the range is going to include -1 to 1.5. Okay? Number 3, my range is from negative infinity to positive infinity. The graph goes on forever in the negative direction and forever in the positive direction. So that should be negative infinity to positive infinity. Okay, number 4. All right, my range. Again, all we care about on range is the y values. So it doesn't go to negative infinity because it has a clear stopping point, right? But this point goes from the very bottom of our graph is negative 10. And then the very top of our graph is never ending. So it's going to start at negative 10 and it's going to go up forever to positive infinity. So here we are at negative 10 and we're going up to positive infinity. Okay, that's number 4. All right, my range here. I'm going to have to estimate just a little bit. But let's just say there's a dot. Okay, we can make this adjustment. Let's say that there's an actual dot there at negative 6. So my range for this one is going to include negative 6, and it's going to go up to infinity. Okay, so our range starts here at negative 6, and it goes up forever on the y-axis. So that's why it goes to infinity. Okay, number 6. What's the range? Again, we only care about y values. Starts at 0, and it goes up forever. So this is going to include 0 and go up forever to infinity. So number 6, range is 0 to infinity. Okay, number 7, the range. This one has a lowest point right here at negative 1 and a highest point here at positive 1. So that's going to be my range. It's going to be from negative 1 to positive 1. Okay, now we're going to go to increasing and decreasing. Okay, I'm going to do these together for each one because these kind of go together. All right, so we talked about increasing. Increasing is when you're looking from left to right. So I go to the furthest spot on the left for my graph, furthest spot on the left, and then I trace the graph. What's happening? My graph is going down right now. So from negative infinity all the way until the point of 0 right there, my graph is going down. So going down means decreasing. So we are going from negative infinity to 0. My graph is decreasing. And I don't do the square bracket on the end of 0 because at 0, it's 0. 0 is not increasing or decreasing. Okay, so the increasing, decreasing ones pretty much almost always will have the normal parentheses, not the bracket parentheses. Okay, so when is it increasing? Well, after 0, after x equals 0, my graph goes up forever. So from 0 to infinity, it's going to be increasing for number 1. So it's increasing from 0 to infinity. It's decreasing from negative infinity to 0. Okay? Let's look at number 2. All right, again, start on the very far left of your graph and trace the graph. What's happening? My graph is going up. All right, my pencil is going up when I go from left to right. So this one looks like it's always increasing. Okay, there is no area, all right, there's none or not any that's decreasing. So when is it increasing? Well, it starts increasing at 0, right, and it's going up until infinity. Okay, so we're going from 0 to infinity. You could probably make the argument that this could be square bracket on the other side of 0. It's okay. I would take either one in this case. Okay. Oh, I'm sorry. Make one adjustment. All right. I assume that this was an arrow up here, but it stops, right? Our graph stops at 6. So our increasing value should just be from 0 to 6. Okay, I apologize. All right, let's look at number 3. When is this one increasing? So Again, put my pencil on the very far left. I trace it. Well, it looks like it's going up from negative infinity until x equals 0. And then after 0, it's increasing again. So we're going to have a union here. It's going to be increasing from negative infinity till 0. And then again, on the other side of 0, it increases. So 0 to infinity. So we have negative infinity to 0. And then again, 0 to infinity. And at 0, it's constant. It's leveled out. Okay, it's never decreasing. So this graph is never going down. It's always going up from left to right. So there are no intervals where this graph is decreasing. Okay, increase and decreasing for this one. Well, very far left, right? From negative infinity all the way until the x value, right? That's not negative 10. That x value right there is 5. Okay, so I am decreasing right here at 2. All right, x equals 3, it's still going down. X equals 4, it's still going down. At x equals 5, it stops going down. It reaches its lowest point. So our graph is decreasing from negative infinity up until the point x equals negative 5. And then because it jumps back up and goes back up in the positive direction, all right, it's increasing from negative 5 to infinity. Okay? Oh, it's positive 5. You're correct. Positive 5. Okay? So from positive 5 to infinity, it's increasing. From negative 5 to positive 5, it's from negative infinity to positive 5, it's decreasing. All right, increasing, decreasing for this one. So this one, it's got a little bit more. It's going to have some unions in it because our graph is kind of going down, bouncing up, going back down, then bouncing back up. So from negative infinity all the way until, we'll call that negative 1 right here. All right, it looks like it's going down. Okay. And then again from 0, all right, until we'll call that 1 as well, it's going down. So that's going to be the two intervals that we're looking at. All right, we'll say that this is decreasing from negative infinity to negative 1, and then union from 0 to positive 1. That graph is going down from left to right. So now we got to come back and think about, when is it increasing? Well, these are the two instances when the graph's going up. Okay, right there and right there. So those values are from negative 1 to 0, and then from 1 to infinity. So that's our increasing interval. We are from negative 1 to 0, union 1 to infinity. Okay? So we got number 6. We're doing great on time right now. All right, number 6. This one appears to always be increasing. From left to right, my graph is always going up. It's never going down. So there are no values when it's decreasing. And it's going to be increasing on what interval? Well, that interval starts here at x equals 0.5, and then it's going to infinity. So our increasing interval is going to be from 0.5 to infinity. And lastly, number 7. All right, this one has, it's going to have a couple parts to it. So when is this one increasing for us on this interval? And this one actually is going to be harder to answer. You would need to have some endpoints on this to answer, because this one actually has several, all right, because this goes on forever and ever and ever. All right, so let's just mark that one out for right now. Okay, we're going to mark out increasing and decreasing. On number 7, it would make sense if you had something for increasing like from here to here, all right, and estimating those points, maybe 0.75 to 0.75. Okay, that would make sense. All right, but let's go look at positive and negative. That's what I want to focus on now. So back to number 1, all right, positive and negative. So positive is anything that is above the x-axis. Okay, so our positive regions are going to be the x intervals, right? We're still looking at that x-axis. When is the graph above the x-axis? Well, this graph is always above the x-axis, right? It never comes down here below the x-axis. So the intervals when this is positive, right, like at negative infinity, you're going to have some value up here on your graph. Okay, at positive infinity, you're going to have some value up here on your graph. So it's always above the x-axis. So this is from negative infinity to positive infinity. All right, and there are none for this one that are in the negative range. Okay, let's look at number 2. So again, start with a positive. When is it above the x-axis? Well, at x equals 1, that is kind of where everything happens. That's when y is equal to 0. After x equals 1, it goes above that x-axis. So it's positive, all right? It's going to be positive from 1 to 6. All right, and closed on 6. It's open at 1 because at 1 the value is actually 0. And 0 is never positive or negative. That's why we use the curved bracket around the 1 and the closed bracket at 6, because 6 is positive. Okay, when is this one negative? Well, this is negative at x equals 0, right? And then it goes up until x equals 1. But we can't include 1. So it's from 0 to 1. That's when our graph is negative, from 0 to 1. Okay, let's look at number 3. All right, when is this graph positive? Okay, well, you kind of need to know what that point is. All right, but it's positive when it's above this right here. Okay, so above that point, whatever we claim that point to be, maybe, I don't know, 1.25. Let's just say it's that. That's not going to be exactly what it is, but let's just do that for the sake of our argument here. All right, so it is positive on the other side of negative 1.25. So it's going to be positive from negative 1.25 to infinity. Okay, and it's negative on the other side of that. So from negative infinity to negative 1.25. That's the values where it's below the x-axis. Okay, and again, that point, if we had the graph on Desmos, we could actually click that point, see what that value is. But we're just going to estimate. Okay, let's look at number 4. All right, this one doesn't have any positive or negatives. Okay, if it did, we could do it, right? We could talk about it. So again, your x-axis, it's negative, all right? Right here, right before 2, and then right there, right after 8. That would be your interval that it's negative. Okay, look at 5. All right? Yeah, great question right here on 5. So there's your dividing line on the x-axis. When is it positive? Well, it's positive on these two pieces on the ends of our graph right there. So that's going to be from negative infinity. Okay, negative infinity, it's always positive out here, right? And then it stops being positive at negative 2. And then it starts being positive again at 2, and then it goes all the way out here to positive infinity. So this one's going to have a union, negative infinity to negative 2, union 2 to infinity. Okay, when is it negative? Well, it's negative after negative 2, stays negative up until 2. All right, that W there in the bottom, that's going to be the pieces that it's negative. Okay, and those are in between negative 2 and 2. So from negative 2 to 2, it's negative. Our graph is negative. Okay, number 6. When is the graph positive? Well, when is that graph above the x-axis? There's your x-axis. This graph is always above it as long as you get above that 0.5 spot. So from 0.5 to infinity, it's positive. And we can't use the square bracket on 0.5 because at 0.5, the value of that is actually 0. 0 is neither positive or negative. Okay, when is this one negative? Well, it's never negative, so none. Right there. Okay, and number 7. Positive, negative. All right, again, this one's going to have a lot of different ones. Okay, let's mark that out right here. Okay, positive and negative. Not worry about that one for number 7. Okay, last piece of information we're going to talk about. These will go very fast. We're going to look at our x-intercept and our y-intercept. So x-intercept is where the graph crosses the x-axis. Y-intercept is where the graph crosses the y-axis. All right. So this one doesn't have an x-intercept, right? The graph never touches the x-axis, won't ever touch the x-axis. So there is none. And then for your y-intercept, all right, what y value? Y equals, it touches the graph at y equals 1 right there. Okay? Number 2. All right, this one does have an x-intercept. It touches the graph at x equals 1. And it has a y-intercept. It touches the y-axis at y equals negative 1. Okay? Look at number 3. All right, well, our x-intercept here, if we're still using this same point, our x-intercept would be at x equals negative 1.25. I didn't ask you for the y-intercept, but the y-intercept would be here at y equals 2. Okay, didn't ask for that on number 4. I did ask for the x-intercepts on number 5. Okay, those x-intercepts I already have them circled, at negative 2 and at positive 2. So this one has 2, and that's okay. You would say x equals negative 2 and x equals positive 2. If I asked you where the y-intercept was, I didn't ask you for that one, but it would be here at negative 4. Okay, number 6. Where's the x-intercept on number 6? Where it crosses the x-axis. All right, that value is at, we've been saying that is x equals 0.5. Okay? And then our x-intercepts here, it's harder to tell what these points are. Okay, but that's my 3 x-intercepts there. All right, you can just circle them. These will be more clear on a test or an assessment. It'll be a clear number right there for you. All right, and the y-intercept is at y equals 0. That's the only spot.